The new technological revolution poses increasing challenges to employers, but also to the academic community. Along with demands for productivity, energy transition and automation in production, the issue of worker well-being and acceptability of work processes arises. How to improve the work of employees who work with collaborative robots, their efficiency and job satisfaction. How to organize work in Industry 4.0 for the benefit of workers are the goals of the European MindBot project. In the desire to solve some of the challenges in Industry 4.0, which is centered on automation and digitalization, the project partners created a prototype of a collaborative robot, the MindBot cobot, which allows the worker to do the work in a flexible and personalized way. The guidelines for the organization of work in production facilities where cobots are used are of great help to employers. The results of the project, as well as the prototype of the MindBot robot, show how in Industry 4.0 workplaces and processes can be designed where the level of challenge and the difficulty of work tasks match the abilities and skills of the workers, and such workplaces also enable the employment of people diagnosed on the autism spectrum.
The MindBot project since the beginning wanted to have a multidisciplinary approach by involving engineers, but also experts in IT and artificial intelligence, but also psychologists, sociologists, designers to tackle the world of collaborative robotics from several different directions.
So my name is Carla Finucchiaro and I'm the project manager of the MindBot project. When we started, we needed to put together a number of different expertise that could work, have a complementary expertise and work together toward the same goal.
MindBot is a project which aims to identify methods and implementing solutions for promoting good mental health in workers of the manufacturing industry, small and medium-sized enterprise, which uses cobot in their production lines.
This project is important because the people with the autism spectrum disorder can find a satisfying job, and also because the industries can integrate these people, and in the same time, if in the industry we speak about autism spectrum disorder, this team can sensibilize in interior of the industries in general.
As a psychologist with an expertise in high-functioning autism spectrum disorder, my role in the project is to define some good practices to help neurodiversity at work. So basically my goal is to define a job model, employment model, to help individuals with autism spectrum disorder and their job placement.
As a product designer with expertise in user experience analysis, I have addressed my research activity to improve human-robot interaction and to make it more accessible for people with autism spectrum disorder.
As coordinator of the MindBot project, Medea was involved in all three phases of the MindBot project. The first phase was on field activities to gather information in both industries and in laboratories, collecting evidence from a psychological and physiological perspective. The second phase involved the development of technologies to be installed in the cobot prototype, which in the third phase is going to be tested in laboratory and industrial scenarios. And this third phase is the phase that we are actually inside at the moment.
So the main problems, if we can say so, they were not problems, items to be solved were to overcome the differences in cultures, languages and different attitudes. And so the role of the project manager had, since the first First part of the project is to ease this communication, and there are different tools and ways to do that. At the end, we have all learned a lot because also from a project management point of view, we gave our contribution in this communication of project results and activities.
The main impact of this project is based basically on the leading idea of this project, which is try to redesign workplaces in order to make the difficulties related to the job task matching with the skills and capabilities of the workers in such a way to promote good mental health and to prevent negative experiences such as anxiety, apathy, boredom that frequently occur to the workers in highly automated workplaces such as manufacturing industry.
For our knowledge, MindBot project is the first project that focuses on the mental well-being in the industrial scenario, not focuses just on the physical safety. So basically our aim is to identify a job employment model and to, for example, help the individuals in their environmental accommodation, because as we know, individuals on the autism spectrum disorder might suffer from hyper or hypersensitivity, help them, for example, in their social interaction with the colleague, but also with the cobot itself, and then have more predictability on their daily tasks.
In fact, working with complex technologies can create some negative experience in worker. We are developing a multimodal device aimed to make explicit the implicit information of cobot platform in order to make the user aware of cobot's activity and gain control over the situation.
What has not been done so far in research and development is looking at the effects of collaborative robotics on the mental well-being of workers using them. And this is, we think, definitely a strength of the MindBot project.
And this has been really a great effort that the entire consortium made. And I think that this has been really appreciated, acknowledged and really appreciated by the European Commission.
Here in STIMA Institute of the National Research Council of Italy, we had the responsibility and the task of developing the control system of the cobot and developing all the integration of the part developed in the MindBot project. We also had some other tasks like estimating the fatigue of the operator and developing the camera system for monitoring the operator while working.
My role in the MindBot project was to carry out parts of the experimental sessions in the phase 2 and in the phase 3 of the MindBot project. Amico is a multimodal communication device able to improve the well-being of the autistic workers interacting with collaborative robots.
In the project, I'm working on kinematic acquisition and estimation of biomechanical parameters of the operator during the task in the work cell.
The focus on the operator. So I think the most important part that has been faced within the MindBot project. So not only from a technical point of view, but from the state of the operator and the well-being of the operator. So this is surely had to face many different technical aspects, but the focus of all the project was on the operator.
The effectiveness of the device was evaluated carrying out some experiments with people affected by autism spectrum disorder. In particular, these people were either high, medium or low functioning autism, and the results were that the people with high functioning were more prone to get the benefits of the device, while the medium and the lower ones were not capable of fully get the features of the device itself.
It is possible to estimate biomechanical parameters during the task with markerless tracking systems and biomechanical models. In the project, we compute the kinematics and the dynamics of the movement and also the physical fatigue of the operator. It is important to evaluate biomechanics and physical fatigue because they contribute to the overall well-being of the operator.
The work cell integrates a cobot with a new control system, some camera system monitoring what the operator is doing, many different algorithms in order to interpret all the data, and an avatar which interacts directly with the operator and knows which are the tasks that the operator has to do.
The University of Milano is contributing to the MindBot project from two perspectives. One perspective is the conceptual framework concerning what is well-being at work and how can we measure it in the context of the workplace, and how can also we analyze data and interpret them. The second contribution concerns the well-being of organizations, so how the introduction of cobots in the Industry 4.0 impacted on organizations, not only from the individual point of view of the single worker, but on the productivity and the organizational climate as a whole.
We have used a very special measurement tool, which is experience sampling method. It's a method that allows us to record in real time the experience of workers while they do the work. It allows us to capture the fluctuations, how they move throughout the different tasks they have, to see both the type of task and the type of experience.
However, one of the main issues when talking about cobot's introduction within the workplace, especially as regards manufacturing sector, is that we have to consider how work itself changes due to the introduction of cobot. Because there are many characteristics that may be impacted by the introduction of cobot, such as the expected increase or decrease in terms of autonomy, for example, or the role of human itself within the workplace that adopt cobot.
Please let me first say that MindBot project was a unique opportunity to collect real-time information on the quality of experience of both cobot workers and volunteers in a lab scenario. There are many differences in perspective, methods and also expertise employed from the different parsers. So a good way to integrate it is having a common goal and proceeding towards it. And for the MindBot project, it was promoting the mental health and the well-being of the cobot workers.
I work with a team that is responsible for understanding and exploring the implications that the introduction of cobots has on work and on organization of work, having the main or the broad objective into promoting workplaces that introduce such a technology and that not only sustain higher productivity, but as well the development of humans from a work and organization of work perspective.
For many years, psychological research investigating well-being at work actually investigated ill-being, burnout, fatigue, dissatisfaction with work. What we are doing, what is psychology doing in the recent years, and what we are doing in the MindBot project is try to focus on the positive side of the work experience, and especially emphasizing which specific conditions in the workplace can foster a very key positive experience, which we call flow experience, which is the best experience we can have in daily life and which can facilitate workers' well-being but also productivity at work.
We focused on the experience sampling method, which is validated and well known to measure quality of experience in real time. So through the repeated measurement of different time points in the life and in the work experience of workers, we managed to get both the tasks that we're working on and the kind of experience that was associated with it. And that allows us to see how it could move, how it could fluctuate throughout the different tasks.
I think that as regards the impact of MindBot project on organization, it is very important the type of contribution that this project may provide, especially to managers. in the sense that they should be aware that when considering the introduction of cobot, this is not something that implies only a technological perspective or a process-oriented perspective. What should be done from a managerial and an organizational perspective is considering the effect of technology on people.
Well, the main finding is that cobot workers are experiencing a flow during their activity with the cobots, even with the current versions of the cobots. However, they also feel constrained and obliged during this kind of work. A new cobot with improved features like the MindBot could help in changing this criticism, in adapting to the different feelings of the workers.
All in all, the cobot introduction brings out many positive aspects into increasing the productivity of processes and of the worker performance. On the other side, the introduction of cobots as well supports the design of a more inclusive workplace, as it allows the inclusion of aged workers and of women in the workstation. So we could say we have a bit of a win-win situation here.
For KUKA, the main activities in the project MindBot were in phase 1. There we spent a lot of time and efforts in acquiring the companies and organizing the data collection and then going through with it and also analyzing the data. For each company, we would accompany the respective participating workers during their shifts, observe them, and then a couple of weeks later we would interview them on the experiences that they were having with the interaction of cobots. And in addition, it was also important for us to include the management perspective, focusing on the implementation of the cobot, how they were introduced to the workers, questions about training and mental well-being of the workers, so that we would get a whole picture. And then the analysis of both the interviews and the observations were the base for our baseline assessment, which we then forwarded to the technical partners who in phase 2 developed the MindBot avatar, and later in phase 3 we'll be testing this avatar. This is a novelty and might very well be the step towards Industry 5.0.
As a researcher for the National Research Council of Italy, we are one of the technical partners in the MindBot project. Our role in the project is twofold. So, on the one hand, we are working on the robot control part of the project, and on the other hand, we are also dealing with the biomechanical assessment of the operators that are involved in the collaborative assembly or task in collaboration with the robot that we are studying.
My team conducts research at the cross-border of artificial intelligence and human-computer interaction. In the MindBot project, we are responsible for the analysis of the states, affective states of the human worker, in particular frustration, boredom, but also positive states such as flow.
First phase was a baseline phase in which we wanted to collect data about how workers are currently experiencing their collaboration with robots. So from the CNR point of view, this resulted in building a lab-based reproduction of a working cell and having participants come in and test and work with the robot while we were collecting data about their experience.
The challenges will be to have human workers and cobots work in a team. We call this paradigm collaborative AI or human AI partnership. Collaborative AI considers the complementary skills of the human workers and the AI. It also involves that the AI or the cobot adjusts to the human worker in real time, for example by adapting its motion trajectory.
Phase 2 was instead the evaluation of some technological solutions that we wanted to explore to make this collaboration better for workers. So again, from our perspective, this meant the integration and the implementation of these technological solutions and the testing with participants that came to the lab and tried the experience with the cobot.
Collaborative AI also involves that the AI or the cobot knows when to defer a task to the human worker, for example in unforeseen situations or in situations where the cobot only has a small amount of data.
In phase 3, we wanted to actually have a measure of how good these solutions were if compared to the baseline, so to the current state of the art. And again, from our perspective, we had participants coming in, the same ones that we had for phase 1, so that we could compare their experience.
We can reduce certain reservations and concerns about robotics and artificial intelligence by involving all stakeholders at a very early stage of development. When the robot is already in operation at an industry site, it's definitely too late. We need to run workshops with end users already when the cobot is being designed, and we call this co-design with end users.
So one important aspect of the project is actually the evaluation of any adaptation that may be needed for the industrial work cell in order to have a better inclusion of workers characterized by the autism spectrum condition. Literature is already showing that Industry 4.0 may represent a great inclusion opportunity for this group of individuals, and this is why for the project we involved some of these participants which worked at the cell for a few days, and we have very interesting results. For instance, we saw that in some cases the working performance of people with the autism spectrum condition can even exceed the average performance that we recorded throughout the whole project.
I do hope that the MindBot project will inspire further research that will, in the end, contribute to more human-centered workplaces.
So, my institute, the German Research Center for Artificial Intelligence, DFKI in German, was working mainly in the analysis of the emotional status of the worker. And the goal of our institution was to give an interpretation to these raw signals and transform them in something explaining what is the emotional status of the worker. According to this emotional status, our second goal has been to create an avatar of the robot. So it's kind of the representation in the human-like representation of the soul of the robot. To give the worker a more intuitive way to communicate with the robot, having something in front that is not made of metal but resembles a human being. As an example, whenever we can detect that during the working session the worker has a moment of anxiety or stress, in this case the avatar is turning towards the worker and saying some sentences. Not really to start a communication, because having a natural language-based communication with the avatar was beyond the scope of this project, but just the presence of the avatar and the fact that it is initiating a communication with the worker when some emotional state is not optimal, this is enough to create a kind of self-awareness, and the worker can understand himself and try to get in a better state again. So it's not an avatar that wants to act as a psychologist or as a therapist, but more to raise the self-awareness of the worker.
So we are here at Byrix. Byrix is a spin-off company of the Catholic University of Leuven, KU Leuven. So in the MindBot project, what Byrix is doing, we monitor people in an online way in real time while they are doing activities, because mental monitoring often goes with like heart rate variability, but that is not working on moving people. Yeah, we monitor them while they work with robots, which is called the cobot. And that is interesting because most people collaborating with a robot are more stressed. And thirdly, we try to make it that they relax more, because the robot is controlled, taking into account the mental state of the person working with it.
From the psychological assessment via the questionnaires, it was found that when the worker is working with the cobot, the quality of experience is commonly good. When we did the same analysis starting from the physiological data, we also estimated the level of mental energy while working with the cobot that was slightly higher than the level of energy when working in the production line without the cobot, but it was more consistent. That means that while they are working with the cobot, the level of energy during that time fluctuates less than when they are performing other tasks in the production line.
Industry 4.0 is about people who have to learn to work with advanced technology. Yeah? In this time, we use artificial intelligence. So that means something is measured on the person without the person realizing. That goes to the cloud, immediately comes back, and in the phone of the people, they can see how much did I make energy, did I make this day? Do I have leftover? You can all follow it in real time and you get tips. And what is the final idea? That people, they work more relaxed, they work more what we call in flow, yeah, and that the company gets better results. Because in a lot of production processes, the results is depending on the mental focus of the people. And mental focus, that is fine, but you cannot be distressed, too much stress, because then you will make mistakes. And when you have too low focus, it will also not go. So that is what we do in this very innovative project. I think that a lot of people, as it was also always in history, are scared about changing things. So what we have to do is to inform people about the benefits and the risks of new technology. It's about education, it's about informing, and education becomes very important.
The role of our team from the University of Rijeka is focused on organizational assessment, which has been performed at two levels: person level, individual worker, cobot worker, and the organizational level at the management level. And we also applied two kinds of approaches: quantitative and qualitative approaches. Individual level of workers is important, but also the way the companies introduce cobots and organize the work is very important, because as I said, team engagement is actually mostly attributed to the management of the company. And also we had additionally some data collected in a laboratory because student volunteers were working with the new cobot, and also they provided very important information on task analysis, but also open-ended questions about positive experiences with the new cobot, negative experiences, and actually suggested some possible improvements, which is very important information for the results of the project. Now we are actually finishing collecting data with installing the platform in the organization to validate it within the workplace in the company.
The European Agency for Safety and Health at Work included this project in a new campaign. So that campaign will be European campaign, and MindBot is an example of how digitalization can be used to promote mental health.
MindBot is a step forward into Industry 5.0, centered on the well-being of workers, and shows how it is possible to make progress that is humane and that fosters our ability to grow and develop as a society.